Alright, in this tutorial we are going to mesh this model and export it as an FBX for import in Unity. Precondition is that we have a properly organized model and a properly textured model. I will go layer by layer, and the first layer I want to isolate is the roof layer from the Rhino geometry. So the layers for the mesh geometries have already been prepared. And on that layer, we find these geometries, so this green roof, a roof that has a plaster material, and yet another that has also a plaster material. We are going to select these geometries, hit the mesh command. By default, we get these simple controls, maybe with the slider in the middle. We can do a preview, and when you see vertices appearing inside planar boundaries of the meshes, then these vertices are not used, as are these rectangular vertices. So this is a mesh that is too complex for our needs. There is no benefit, and in fact, that slows down our rendering in Unity. So we can drag this slider to the left, get another preview, and also in this command line here, we get a report of how many polygons were created, and the lower the number, the better. There are also detailed controls where we can fine tune our meshing. Worth checking those out if you still get vertices inside the planar surfaces. I'm happy, so I click OK. So, and I have created these meshes, which I'm now going to select. So I'm just filtering out the meshes. Better visible in the shaded view probably. And when I go to properties window, I just have 4 meshes, and I can put them on the mesh roof layer. And I'm going to repeat the process by next activating the wall layers of the Rhino geometry, turning off the roof mesh layer. So here we just have the walls, or what could be walls. We are going to select the walls, again hit the mesh command, hit preview, everything looks good here, no unneeded vertices. I hit OK. Again, I select just the meshes in the properties window, so this would be 20 closed meshes, and I'm going to move them to the mesh wall layer, and so forth. So I'm going to do this for all the layers. Each time I create the meshes for the Rhino geometries and move the meshes to the corresponding mesh layer. And when I'm done, I continue recording. So I'm now done. I have turned off all the Rhino geometry layers. It just turned on the mesh geometry layers. In the rendered view, I can check if everything is complete and properly represented. So our textures, everything came across in the meshes. The next step we should do is identify when we select all these meshes. So this would be 39 meshes now, as the command line reports, or the object properties also says 39 meshes. We can and should reduce the number of meshes, because all these individual meshes will become individual game objects, which will be rendered individually in our simulation, and the fewer individual meshes we have, the fewer of these meshes will have to be rendered in real time, and that can speed up our simulation, meaning it's going to run more fluidly. So how can we do that? Again, we go layer by layer, and I'm going to start again with the roof, deactivating all the other mesh layers. And here we find on that roof layer geometries with different textures. So we can only join meshes that have the same material. And in that case, it would be this white plaster material separate from this grass material. So you can go to our materials tab, select the white plaster material, right click, select the objects. So now all the white plaster, all the objects with that material are selected, and we can use the command join to join these originally three meshes into one mesh, which can also receive a name here in the properties, and I call this roof. And if I select this green roof, I can also call it green roof. The name of these meshes will then be the name of the game object in Unity. So let's go to the walls now, turn off the roof. And with the walls again, we have this topic of different materials, and not just that, we also have different texture orientations. So we should not join this mesh and this mesh because it may use the texture orientation, but we can join the other meshes that represent the walls. So what I'm going to do is join all the walls that are on the upper floor. Again, hit join, give the mesh a name, walls upper floor. And then I'm going to do the same by selecting all the walls on the lower floor. And again, use the command join to join all these meshes into just one mesh. That would then be the walls lower floor. These wooden walls, which I keep separate, can also receive a name. So let's call these wooden wall. And this would then be wooden wall slanted. Okay. And we can do the same with the floors. So joining all the meshes that are on the upper floor, give those a name, upper floor, and all the meshes that are on the lower floor should not be joined away, because here we have different materials, so we can only join those that are concrete. In this example, call this lower floor concrete, and this mesh here would then be the lawn. This mesh here would be a staircase. Alright, so when we select these objects, we get the name, which will then become the name of the game object. And finally, for the glass, we can do the same. Select all the objects, join them, if that makes sense. If they are on different levels or you want to have more control, you can also join only those that pertain to a floor. This is not relevant in this example, so I'm joining all of them, and I give them the name Windows. Alright, so let's turn on all the mesh layers, and now we have far fewer meshes in the properties, only 12. So we reduce the number of meshes to 1/3, and that's a good thing, because this will then perform better in Unity. There is one last step of optimization we can perform on this now properly joined mesh model, and that is selecting all the meshes and type reduce mesh. So reduce mesh gives us a polygon count of 508, and we can select this planar only option and hit preview, and that will then further reduce the amount of polygons, so from 508 in this case to 484. We should always go for the lowest number of polygons, so we can hit OK, check in the rendered view whether the textures still look okay. In my case they do. And in the shaded view I will select all the geometries here, go to File, Export with Origin, select a vertex here where I want to have the handle in Unity. The format we save in is Motion Builder FBX. We give this mesh a name, House Tutorial 1 in my case. We want to make sure that the lights and export views are not checked. Map Rhino C to FBXY should be checked. And we hit OK, and we have an FBX that will perform well in our Unity project where we can import it.